Students, here are some reminders during our online discussions. 1. Be on time. Make sure that you log in on your account and follow the given schedule of our discussion. 2. Sit comfortably. Refrain from lying around. Instead, sit comfortably and properly. 3. Avoid unnecessary comments on the chat box. Refrain from sending unrelated sticker comments in our comment section. 4. Stay focused and avoid interruptions. Find a quiet and comfortable place to listen to the lesson. 5. Take down notes while listening or watching. Make sure that you have pen and paper with you throughout our discussion. 6. Extend help to your classmates. Let us learn together and enjoy the rest of our discussion.
Good morning, grade 7 students. Welcome to our Valenzuela Live. It is indeed another day of fun-filled learning explained by science. Our featured topic for today is about layers of the atmosphere. For our most essential learning competency, to discuss how energy from the sun interacts with the layers of the atmosphere. And these are the learning targets that we will be covering. First is to describe the different layer of the Earth's atmosphere. Next is to discuss how energy from the sun interacts with the layer of the atmosphere. Then, to relate temperature and altitude to each layer of the atmosphere. And lastly, to explain what happens to the air in the surroundings as warm air rises. So are you ready? Let's begin! Previously, you have learned about the different ways of using Earth's resources sustainably. If you could remember, there are two types of natural resources on Earth. That is the renewable and non-renewable resources. Renewable resources are resources that can be replaced for a short period of time, while non-renewable resources are resources that will run out and cannot be easily replaced in our lifetimes. It would take millions or billions of years. Example of renewable resources includes the flora and fauna or the plants and animals, water, wind energy, solar energy, and hydrothermal energy. While example of non-renewable resources includes fossil fuel like the coal, crude oil or petroleum, and natural gas. Soil is also considered as a non-renewable resource. For me to see if you really understood the lesson, let us have a drag and drop game. All you have to do is to place or identify the given material that we inside the picture of the natural resource from which it is made. You have 10 seconds to think for your answer. Let us have number 1, the paper. Very good. Paper is an organic material that is primarily made from the cellulose fibers of virgin wood from trees. Next is a jewelry. Excellent. Jewelries are ornamental pieces that are made of materials like gold, silver, gemstones, and other mineral resources that are sourced from the mountain. What about meat? Awesome! Meat is animal flesh that is eaten as food. Then, LPG, or liquefied petroleum gas. Great job! Liquefied petroleum gas, or LPG, is a fossil fuel extracted from crude oil and natural gas. Next in line is the milk. Okay, great! Milk is a nutrient-rich liquid food produced by the mammary glands of mammals. Coming after is a lumber. Brilliant! Lumber is a wood used as construction materials that are cut lengthwise from the trunks of trees. And for the last item, pottery. Outstanding! Pottery is a clay that is molded, dried, and fired into a decorative object. Clay is a natural product dug from the earth or from the mountain. Well done, grade 7 students! Now that you have learned about the Earth's resources, let us now move on to the next topic. Let us start with the 4 different subsystems of the Earth, and these are land, water, living things, and air. The 4 subsystems are called spheres. They are the lithosphere for land, hydrosphere for water, biosphere for living things, and atmosphere for air. So for today's discussion, we will be talking about the layers of the atmosphere. But before we go through to our discussion, let me ask you a question. What do you think makes the Earth different from all other planets in the solar system? Well, the answer is, its atmosphere does. If you are thinking of the same answer as mine, then you are correct. The atmosphere, which is a mixture of nitrogen, 78%, oxygen for 21%, and other gases for 1% that surrounds the Earth. High above the planet, the atmosphere becomes thinner until it gradually reaches space. The atmosphere is an important part of what makes Earth livable.
It blocks some of the sun's dangerous rays from reaching Earth.
It traps heat, making Earth a comfortable temperature. And the oxygen within our atmosphere is essential for life. The atmosphere acts like a blanket of air around the Earth. That means that the atmosphere holds in the amount of heat needed to keep the Earth livable. Atmosphere was coined by 17th century scientists combining the Greek words atmos for vapor and spira for sphere. In short, the Earth's atmosphere is the air and gas surrounding our planet. Earth's atmosphere has 5 and several secondary layers. From lowest to highest, the major layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Let us talk about them one by one. Troposphere is the lowest layer of the atmosphere. It extends from Earth's surface to, on average, about 12 kilometers or 7.5 miles in height, with its height lower at Earth's poles and higher at the equator. Yet, this very shallow layer is tasked with holding all the air plants needed needed for photosynthesis, and animals need to breathe, and also contains about 99% of all water vapor and aerosols, or the minute solid or liquid particles suspended in the atmosphere. So take a look at this picture. This is Mount Kilimanjaro in Tanzania, Africa. Despite having a hot and humid tropical climate, where the average temperature at the base of the mountain ranges from 21 to 27 degrees Celsius. From there, as climbers move through the mountain, the temperature decreases. At the summit, the temperature ranges from -7 to -29 degrees Celsius, which explains the presence of snow caps all year round. This is for the reason that in the troposphere, temperatures typically go down the higher you go, since most of the heat found in the troposphere is generated by the transfer of energy from Earth's surface. The troposphere is the densest layer of the atmosphere, compressed by the weight of the rest of the atmosphere above it. Most of the Earth's weather happens here, and almost all clouds that are generated by weather are found here, with the exception of cumulonimbus thunderclouds, whose tops can rise into the lowest parts of the neighboring stratosphere. Most aviation takes place here, including in the transition region between the troposphere and the stratosphere. Next is the stratosphere. It is located between approximately 12 and 50 kilometers, or 7.5 and 31 miles above the Earth's surface. The stratosphere is perhaps best known as home to Earth's ozone layer, which protects us from the sun's harmful ultraviolet radiation. Because of the UV radiation, the higher you go into the stratosphere, the warmer temperature becomes. The stratosphere is nearly cloud and weather-free, but polar stratospheric clouds are sometimes present in its lowest, coldest altitude. It's also the highest part of the atmosphere that jet planes can reach. After which is the mesosphere. It is the coldest layer of the atmosphere. It is located between 50 and 80 kilometers, or 31 and 50 miles above Earth's surface. The mesosphere gets progressively colder with altitude. In fact, the top of this layer is the coldest place found within the Earth's system, with an average temperature of about -85 degrees Celsius. The very scarce water vapor present at the top of the mesosphere forms noctilucent clouds, the highest clouds in the Earth's atmosphere, which can be seen by the naked eye under certain conditions and at certain times of the day. Most meteors burn up in this atmospheric layer. Sounding rockets and rocket-powered aircraft can reach the mesosphere. Following is the thermosphere. It is located between 80 and 700 kilometers, or 50 and 440 miles above Earth's surface. In this layer, temperatures increase with altitude due to the very low density of molecules found here. It is both cloud and water vapor free because there are relatively few molecules and atoms in the thermosphere. Even absorbing small amounts of solar energy can significantly increase the air temperature, making the thermosphere the hottest layer in the atmosphere. The aurora borealis and aurora australis are sometimes seen here. The International Space Station orbits in the thermosphere. And lastly is the exosphere, located between about 710,000 kilometers or about 440 and 6,200 miles above Earth's surface. The exosphere is the highest layer of Earth's atmosphere and at its top merges with the solar wind. Molecules found here are of extremely low density. So this layer doesn't behave like a gas, and particles here escape into space. While there's no weather at all in the exosphere, the aurora borealis and aurora australis are sometimes seen in its lowest part. Most Earth satellites orbit in the exosphere. But now, the big question is, where does space begin? While there's really no clear boundary between where Earth's atmosphere ends and outer space begins, most scientists use a delineation known as the Kármán line. It is located 100 kilometers or 62 miles above Earth's surface to denote the transition point, since 99.99% of Earth's atmosphere lies beneath this point. Furthermore, a February 2019 study using data from the NASA or European Space Agency Solar and Heliospheric Observatory or SOHO spacecraft suggests, however, that the farthest reaches of Earth's atmosphere is a cloud of hydrogen atoms called the geocorona. They actually extend nearly 391,000 miles or about 629,300 kilometers into space, far beyond the orbit of the moon. And now, for you to be able to easily remember the layers of the atmosphere in proper order, please take note of this mnemonic device. The silly mouse tries to escape. The word "the" for troposphere, silly for stratosphere, mouse for the mesosphere, tries for thermosphere, and escape for exosphere. The silly mouse tries to escape. To summarize the ideas that you have learned from this lesson, you have to unjumble the words to complete the following statements. Number 1, the blank is a layer of gases that surrounds the Earth. Correct. The answer is atmosphere. Number 2. Earth's atmosphere is made up of blank layers. Great. The answer is 5. Number 3. Weather occurs in the blank. Nice. The answer is troposphere. Number 4. The blank contains our ozone layer. Good job. The answer is stratosphere. Number 5. Meteors burn up in the blank. Keep it up. The answer is mesosphere. And now, for our assessment, get your paper and pen and answer the following questions by choosing the correct letter and answer. Let's get started. Number 1. Why is the ozone layer in the stratosphere critical to life? Is it A. Ozone absorbs ultraviolet radiation from the sun? B. Ozone provides oxygen for animals to breathe? C. Ozone is an essential element for organisms? Or letter D. Ozone is needed by plants for photosynthesis? Awesome! The ozone layer is critical to life because it absorbs UV rays from the sun. Next item, number 2. What is the correct order of Earth's atmospheric layers from bottom to top? A. Stratosphere, troposphere, mesosphere, thermosphere, and exosphere. B. Stratosphere, troposphere, thermosphere, mesosphere, and exosphere. C. Troposphere, mesosphere, stratosphere, thermosphere, and exosphere. Or letter D. Troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Brilliant! The correct order of Earth's atmospheric layers from bottom to top is letter D. Troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Number 3. Some jet airplanes fly in a layer of the atmosphere where temperature generally increases with altitude. What is this layer of the atmosphere? Is it A. Mesosphere, B. Stratosphere, C. Thermosphere, or D. Is it A. Mesosphere, B. Stratosphere, C. Thermosphere, or D. Troposphere? You've got it right. Jet airplanes fly in the stratosphere. Number 4. Why does the troposphere experience the greatest amount of atmospheric pressure compared to the other atmospheric layers? Is it A. It produces the ozone layer? B. It has the highest temperatures? C. It is the region in which weather occurs? Or letter D. It contains a high concentration of gas particles? Superb! The troposphere experiences the greatest amount of atmospheric pressure because it contains a high concentration of gas particles. Next, last item, number 5. On Mount Everest, the temperature decreases as the altitude increases. The summit or the highest point of this mountain is in which atmospheric layer? The A. Mesosphere, B. Stratosphere, C. Thermosphere, or D. Troposphere? Perfect! Mount Everest is found within the atmospheric layer of the troposphere. How many correct answers did you get? Can you give me a heart or a wow emoji if you were able to get the perfect score? Because great, in case you weren't able to get all the items perfectly, don't worry. What you did today is a good start towards improvement. Also, your science teacher will have a follow-up discussion. Mom and Sir will be more than willing to assist. So it's time now for the question and answer. If you want to clarify something that has been discussed, you are free to type your concern. I will accommodate 3 questions from the comment sections, and other questions can be discussed in your follow-up discussion. Okay, so let me see. First question is from Rich Lacangan from Valenzuela National High School. They ask, what is the basis for dividing Earth's atmosphere into layers? Well, that is a very good question, Rich. The basis for dividing the atmosphere into 4 layers are the difference in temperature gradients and wind pattern. Also, there are some significant differences in the chemical composition of these layers, particularly when it comes to the amount of water vapor and other trace gases. I hope I was able to answer your question. Okay, next is from Gina de la Vega from Lawang Baton National High School. Ask, how do auroras form? Well, Sheena, in the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from the Earth's atmosphere. The energy released during these collisions causes a colorful glowing halo around the poles, forming auroras. If you're near the North Pole, it is called an aurora borealis, or northern lights. If you're near the South Pole, it is called an aurora australis, or the southern lights. Okay, last question is from Francine Araneta from Huawangpulo National High School. So what will happen if the ozone layer is totally destroyed? Well, a diminished ozone layer allows more UV radiation to reach the Earth's surface. For people, overexposure to UV rays can lead to skin cancer, cataracts, and weakened immune system. Increased UV can also lead to reduced crop yield and disruptions in the marine. So thank you so much for sending your questions. Those are really good ones. I am happy that I was able to capture your interest and share new learning with you. I am very sure that you will be able to complete the task in your learning packet. Again, thank you very much for making yourself connected in our discussion for today. Keep safe, everyone.